Hello, 6th grade math students. This is chapter 12.1. In chapter 12, we're going to be learning all about the surface area and volume of solids. We begin with nets of solids. Let's begin by reviewing special prisms. A prism is any solid with two parallel congruent bases joined by faces that are parallelograms. A prism is named by the shape of its base. Before we go any further, let's also review the vocabulary terms you need to recall when looking at prisms. First, we have faces. The face is the flat polygon surface of any solid. Okay, so you'll notice that our cube has 4 faces. It has two bases, which are the flat surface from which the height is measured, or the edge or face that the cube is sitting upon. Okay? Next, we have the edge. The edge is the line that's created where any two faces meet. And finally, we have the vertex, which is the point where 3 edges of a prism meet. We could also call it the corner. Okay? You'll notice that each one of these shapes, the cube, the rectangular prism, the triangular prism, all have edges, faces, bases, and vertices, or a vertex. Let's quickly review the features of cubes, rectangular prisms, and triangular prisms before we move on. Remember, a cube has 6 sides that are equal. The base and the faces are all squares of the same size. A rectangular prism has bases that are rectangles. It's that simple. In a triangular prism, you will see that we have bases that are triangular in shape. That's it. Remember, we name a prism by the shape of its base. Now let's refresh our memory on finding the volumes of rectangular prisms. The volume of a cube is edge times edge times edge, or edges cubed. Okay? With a cube, since each side is a square, the sides are all the same length. So we simply find one length and cube it. In a rectangular prism, we're going to take the length times the width times the height, which we'll write as L times W times H to equal the volume. Okay? Remember, volume is the capacity of the inside of the prism. If we were to pour liquid into the prism, volume would tell us how much it could hold. Let's move on to looking at nets of solids. We'll begin by learning to recognize the net of a cube. I've drawn a cube here, sort of. You know my art skills. Our cube is a type of a prism. If we were to cut along the red edges of this cube, we could lay it flat, and the result would look like this. I've spared you my art. You're welcome. This figure is called the net of a cube. If we were to refold this shape on the dotted lines, we would recreate the cube. Can you visualize how that would work in your head? Take a second and in your head, pretend you're picking up that net and folding along the dotted lines. First, you'll make a box, and then you'll fold this last flap over right here to make the lid. Do you see it? This figure is also the net of a cube. More than one net might form the same solid figure. In this case, this net will also make a cube. Can you visualize folding it up on the dotted lines to create the cube? Before we move on, remember this vocabulary term. A net is a plane figure that can be folded to make a solid. Okay? So as I'm using that term, remember that's what it means. Let's move on. This next picture shows us the net of a rectangular prism. This solid is a rectangular prism, and we know that it's a rectangular prism because it has 6 rectangular faces. Any 2 of the parallel faces could be its base, and we always name the prism by its base. So, a rectangular prism it is. If we were to cut along the blue edges as indicated in the picture, let me highlight them for you here. Along the edges here, 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 and here, we could open this up to create the net, which is shown here. In the picture, the bases have been kept red for you so you can identify them in the net. Can you visualize how you would fold this up and create the three-dimensional figure? Now let's look at this triangular prism. Let's first begin by understanding why it's a triangular prism. The reason this is considered a triangular prism is because the only possible set of bases here are the triangles. Remember, the bases have to be parallel and congruent. So no other 2 sides meet those 2 requirements. There are no other 2 sides that are parallel. So the bases here are the equilateral triangles. In the pictures below, you can see 2 possible nets for that triangular prism. Once again, take a moment and visualize how you would fold along the dotted lines to create the 3-dimensional prism. Do you see it? Let's try a couple of practice problems. I'll apologize in advance. This might be a little small, especially if you're watching on your phone or your iPad. However, the job here is to match each solid with its net. If you cannot see because your screen is too small, we can do this together in the textbook tomorrow. If you can see this just fine, however, please find the nets that would fold into a cube, find the nets that would fold into the rectangular prism, and then identify the nets that would fold into the triangular prism. This next picture has us examine the net of a square pyramid. The pyramid is named by the shape at its base, so this is a square pyramid. Once again, we have cut the pyramid along its edges and laid the resulting shape flat to create 2 possible nets. One net looks like a star. You can probably easily see how the 4 sides will fold in to create the vertex at the very top of the pyramid. The other model looks like this, where you can see the 2 sides will fold up, this side will fold up, and then this side will fold in to close it, to close this final edge. Okay? Let's go on to the next shape. Here's a triangular pyramid and the net of the triangular pyramid. The triangular pyramid has an equilateral triangle at its base, and then the other 3 faces are going to be congruent isosceles triangles. Remember, an equilateral triangle has 3 sides that are the same length. An isosceles triangle has 2 sides that are the same length. Can you see how this folds up to create the 4-sided figure or the triangular pyramid with a triangle on each side? And here's your last task for today, folks. Please match each solid with its nets. There might be more than 1 net for each solid, so look carefully. We have a square pyramid and a triangular pyramid. When I see you tomorrow, we'll do some hands-on work with nets and creating them into their solid shapes. You'll cut out flat versions and fold them up yourselves. It'll really help you learn to visualize this. Until then, thanks for your good work on this today, and I hope your brains are starting to see how these nets work. I'll see you tomorrow.